sensor regression model or COVID models. Narrative analysis and document analysis was also used for the document as well as interview. For objective number, for result question number 5, to understand the determinant factors that affect the willingness to pay of respondents, household survey was used, and this was analyzed by econometric models using data. For the last result question, to model the feature, land cover change and its effects on ecosystem service value, historical land cover change data, drivers, and adapted ecosystem service value option to the target land cover change model. For scenario simulation, a modeling tool known as Trumondo was used. And for the land cover classification, ArcGIS was used. For ecosystem service validation, a model developed by Costanza was used, the ecosystem service validation model. And for statistical analysis between the futuristic land cover change and its effect on the 6 driving forces, material and logistic regression was used. And the ROC tab was used for model validation. Result and discussion. The historical land cover dynamics in the past for several years shows that, with the exception of built-up areas, pushes in service, most of the land cover changes has observed a dramatic and an extraordinary land cover changes between the year 1972 and 2019. This can be shown one by one. The land cover map for the beginning of the study period, 1972, shows that at the beginning of the study period, the study area was dominated by cultivated land, bare land, water body, and riverside vegetation. Generally, the starting period shows that the study area was rich in different systems. The second land cover map for the year 19 shows that the land is increasing and surface were by 649, water body by 40,109. This map for the year 1984 shows that the ecosystem started to decline. The land cover map for 1990 shows that a contraction of ecosystem services. As you can see from the previous map, the cultivated land resistance to increase, and the built-up area starts to increase, and these incremental investments. The land cover map for the year 2001 shows the cultivated land expanded again and reached 1,003 hectares, and this was covered 38% of the land cover type of the study area. Bush and surface increased by 9,404 hectares. Riverside vegetation increased by 4,907. Bare land decreased by 2,000. Built-up area was increased by 100 hectares. Plantation forests by 390. Generally, this period of study showed an increase in the riverside vegetation. For the year 2012, reduction of cultivated land. Cultivated land persists to be the leading change and reached 1,610 hectares, which was 7.9% of the study area. And only the grassland and surface were increased during this period of study. The last land cover shows that the cultivated land decreased by some amount, and it was 64,846 hectares. Bush and surface were also increased by 7,150. Generally, this study period shows that the plantation forest, water body, bush and surface built-up area have expanded due to this rapid urbanization. So, during the last 7 years, The built-up area increased by 8,400 hectares. Cultivated land increased by 38,440. And bush and surface were increased by 4,032. Contrary, an increase of ecosystem service in water body, natural water, riverside vegetation, forest, and grassland was observed. This moral index shows that the spatial autocorrelation between the temporal and spatial trend of land cover change. The p-value shows that there is a strong evidence to reject the nil hypothesis. In the last 47 years, there was no land cover change. And the Morgan I index is 0.965981. This shows the values of the land cover change are more class. The remote sensing data was using the local mineral percent. The data from the interview shows that this was very rich in different ecosystems such as forest, wetland, grassland, bush and surface. The water bodies, lakes, streams, and rivers right. And the result shows that in the last 40 years, there was a shrinkage of the remote sensing data correspond with the data obtained from the local learning person. In agreement with this study, a study in Gebar catchment study area is located. A study by Abraham and Gawin significant land cover change was observed. Regarding the cover change reports, the climate variable one ended shows that an increase change is the average temperature was observed, and the seasonal test shows that the rainfall is decreasing. The human population change, the data from CSA shows that in the beginning of the study period in 1972, the population was 93,163, and in 2019, this reached 556 and 107. The city increased from 100 to 620 per square kilometer. This data shows the population density is much higher than the national population density of Ethiopia, which is 109.22 per square kilometer, as the data of 2018. In line with this study, a study by Abata and Angasa shows that the population growth is among the primary cause for the land cover change in developing countries. The same regression result shows that for each non-stationary land cover change, the drying fortress indicates for the 4-6 drying fortress, the p-value is less than 0.05. The 6 drivers are the temperature, rainfall, elevation model or elevation, slope distance, and have significantly affected the land cover in the study area. And here is the strong evidence to reject the hypothesis that drying forces do not bring land cover changes. To identify land cover drying forces, qualitative data was used. The key informant interview identified that climate condition has changed significantly in the last 47 in the study area. Regarding the institutional aspects, in the study area there was customary institutions locally known as the geographers and the rest. This was a group affiliation. At that time, the local locals were attracting people from other areas, and this aggravated for these land cover changes. Final that influenced the land practices. In 1985, as per the Decmont review, there was a heavy drought in northern part of Ethiopia, particularly in Tigray and Bola, particularly with the steady area. And this shows that severe damage on ecosystem services. The body, bush and riverside was observed. A study in a river shows that decreasing trend in the annual rainfall between 1961 and 2003 was observed. Climate variability has negative on ecosystem service. The data on spatial temporal ecosystem service valuation shows that During the 1972 and 1984, a reduction of 8.5 million USD was observed. A study between the 1984 and 1992 shows that 106 million USD ecosystem service violation reduction was recorded. This indicates severe environmental degradation. And the data between 1992 and 2001 shows that it decreased by 5.7 million of USD dollar. Between the study period 2001 and 2012, it was decreased by 10.5 million USD dollar. And between the last study period, between the 2012 and 2019, an increment of 2.5 USD was observed. This indicates an ecological restoration in the area. But generally, during the last 47 years, a loss of 128.6 USD billion was recorded in the study area. And this data shows that a drastic decline of ecosystem value. At the beginning of study period, the ecosystem value was 100 USD, and it sharply declined in the year 2019. The gradual consolidation between large dynamics and ecosystem service value shows that in the last 7 years, there was a negative correlation between land cover and ecosystem service valuation. Different studies shows that there is a positive as well as negative correlation between ecosystem service and the land cover change. And this data shows that making generalization on the finding to other may lead to erroneous or wrong conclusions. So it is inferred that ecosystem service valuation is location specific. For the research question number 4, regarding the willingness to pay of the Magana City residents, the previous presentation shows that the historical land use pattern, its driving forces, and the status of ecosystem service. This proved in the last 4 years there was an ecological degradation. So the importance of this presentation is the willingness for ecosystem service to improve the historical ecosystem degradation. The map of respondents, 384 respondents were surveyed from the 7 subcities of Magana City, and these 384 were proportionally distributed to 7 subcities. Those are the subcities, and this is the boundary of the state area, as I explained it previously. And during the household survey, the historical land cover conversion was presented to the respondents. The first scenario was the land use cover change will continue, and scenario B was presented as the current trend of land cover change will be halted with the hypothetical willingness to pay for watershed ecosystem service improvement. And this map was also presented. This is the Magana City, and those are the important watersheds which are foundations of ecosystem services that benefit Magana City residents. Along with this, the expected outcome of the willingness to pay was presented using the 3D map. This shows the historical degraded land, and those are the scenarios, the future environmental rehabilitation, and those are the current and future dams. So the expected outcomes were generally for environmental rehabilitation, and this was presented during the household survey. The willingness to pay result shows that 350 respondents were willing to pay as additions to the current environmental as well as utility fees made. From these 352 respondents, 156 respondents were willing to pay 60 Ethiopian, 32 respondents were willing to pay 120, which is a double of the initial P6. 42 respondents were willing to pay 90 Ethiopian, 57 respondents were willing to pay 71.75 Ethiopian, and 50 respondents were willing to pay 30 Ethiopian, and the final 15 respondents were willing to pay 19.33 Ethiopian. Based on the data obtained from the economic model used in the study, based on the sensor regression model or profit model and the bivariate profit model and profit model, the mean willingness to pay is 65 points in Ethiopia. Based on the data obtained, aggregate the willingness to pay and revenue calculated. And if this willingness to pay is adopted by Magana city concerned government bodies, the city government can obtain monthly 8,534,812 Ethiopian dollars. This is the demand curve. The demand curve for the improved watershed ecosystem service. It is negatively sloped. This indicates the fall of the demand for improved watershed ecosystem service as the amount 120 increase, the province's willingness to pay also decreases. This is the result obtained from logic regression or ratio. Willingness to pay was affected by several factors such as resident stay in Wagala city, marital status, size, occupation, frequency for watershed ecosystem service, quantity, and reliability. And the area under the RC curve is 0.7, and this is considered to be previous study focused on willingness to pay for ecosystem such as water. None of the states valued watershed ecosystem service between underlands and its hinterlands. Previous studies applied a single kind of willingness to pay estimation, the single dichotomous choice format. This study adopted the double bound dichotomous choice, and this helped for more reliable result to be obtained. For the result question number 6, how the feature change of land level affect ecosystem service value. The land demand under the 3 scenario for business as usual, payment for ecosystem service, and spatial planning. The land transfer rules, and by employing the major driving forces such as temperature, rainfall, population density, digital invasion model, distance roads were used, and simulation or prediction for the year 2030 were made along with the Agenda 2030. The large land cover change under the different scenarios that by the year 2030, it is predicted that an increase in built-up area will rise from 8,000 hectares to 14,000 hectares at the expense of natural forest, water body, protected land, bush and surface, and reverse vegetation. Business as usual scenario is expected to have negative impact on ecosystem. The second scenario, scenario B, payment for ecosystem service scenario, shows that riverside vegetation will be increased by 1,012.33 hectares, water bodies by 301.62, natural forest by 15 hectares, plantation forest by 300.6.52 hectares, grassland by 498.06. This scenario shows that as compared to the previous business as usual, it will have a positive impact on ecosystem service value. The last scenario, under the spatial planning scenario, it is expected that a balanced land use plan will be implemented and riverside vegetation will be increased by 8,771.90 hectares, natural forest by 88 hectares, plantation forest by 743.86 hectares, water body by 4.5 hectares. This scenario shows that it will have more positive impact on ecosystem service by the year 2030 as compared to the previous scenario for the payment for ecosystem services. The estimation of the future ecosystem service value for the year 2030 shows that in the year 2019, the total ecosystem service value was 32 million USD, and in the business as usual, this will be increased and it will be reached to 27.98 USD. And in the scenario for payment ecosystem service, it will increase to 28.8 billion USD. And in the last scenario, spatial planning scenario, the total ecosystem service value will be increased to $7.2 million. This is the ROC curve. This was used for the calibration and validation of the matrimonial domestication is in the relative operating term. This RAC test 5 driving forces for large and cover change is greater than 0.538, except for really average temperature. The classifier curve closer to the top left corner. The left corner indicates that the better performance. The green line indicates the model does a good job for predicting mean annual rainfall, and from this it's inferred that this will have a significant impact on the future land cover change. Generally, the statistical result shows that the value of the simulation model can be used to predict the year 2030 land cover change and its impact on ecosystem service. Previous study employed single criteria. Study futuristic land cover change. But this study applies statistical, spatial, as well as driver-based method for future land cover prediction. So, from the data, it is suggested that the implementation of payment for ecosystem service supported by spatial planning could have positive contribution to enhance ecosystem service value in the study area. This study is aligned with the Agenda 2030 Sustainable Development. Goal 11 is the making cities and human settlement inclusive service. Goal 11A is support positive economic, social, environmental link between urban and peri-urban areas, and this study adopted urban and hinterland to investigate the nature of the problem. Goal 15 is a mobilization about financial resources to conserve biodiversity and ecosystem service, and this study is using the willingness to pay for watershed ecosystem service. So based on this, this study is aligned with Agenda 2030, Agenda for Sustainable Development Goals. Conclusion and recommendations. For research question number 1, it is concluded that change in land use and cover change has contributed to declining or dwindling of numerous ecosystem services, and this increases the vulnerability to environmental vulnerability, and it is suggested that strengthening ecological restoration, particularly forest, riverside, wetland, and forest body, should get due consideration to strengthen the ecological restoration, and launching regional green infrastructure is also suggested. For research question number 2, it is clear that in the last 47 years, dramatic land cover dynamics over the past 47 years was observed due to the population growth, climate variability, and the institutional changes, and it is recommended that designing and implementing appropriate adaptation strategy to climate change and variability, sectoral integration in watershed management, establishing efficient and effective institutional collaboration. For research question number 3, it is concluded that ecosystem service value varied with land use dynamics. The land cover change, the historical land cover change has a significant impact on spatial and temporal ecosystem service value. The historical decline of ESP or ecosystem service variation showed severe environmental degradation. So it is suggested that valuation can be, economic valuation can be a base for policy making in spatial resource and for effective management of ecosystem services. Mainstreaming ecosystem service value or mainstreaming the economic costs of ecosystem service into spatial policy and decision making, and sustainable land use planning is suggested. For research question number 4, the willingness to pay result shows that households have positive willingness to pay for improved watershed ecosystem services. The institutional and the legal framework in Ethiopia shows that there is absence of policies, institutional and legal frameworks for mainstream payment for ecosystem services. So, establishment of institutional framework and market for ecosystem services is suggested, and facilitating more voluntary donation. The downstream which are beneficiaries of bundles of ecosystem services that benefit urban centers. So city residents should contribute some amount of payment to the upstream for ecosystem service conservation. So it is recommended establishment of national framework in market service. For research question number 5, it is concluded that several factors affected household willingness to pay, and the beneficiaries of ecosystem service are not aware of the source of ecosystem service, and there is a wide ecosystem service supply and demand. And it is recommended that government intervention will be necessary to improve awareness and narrow the gap, environmental education and community-based environmental management, support community and civic involvement in the management to build ownership and long-term support, establishing policy and legal framework for harmonized land use plan in urban and rural areas, and also there is a need to design and implement appropriate spatial planning policy in city region by decision makers. Regional spatial planning along with payment for ecosystem service is also suggested to narrow the gap between ecosystem service supply and demand. And understanding ecosystem service supply, demand inflows is an important aspect for climate change adaptation. For the last research question, it is concluded that lessening of various ecosystem services are expected by the year 2030. This will have a negative impact on ecosystem service valuation. So it is suggested that comprehensive understanding of future land use dynamic scenario and their environmental impact is needed by spatial planners to make sound decisions, planners and resource managers to adopt eco-friendly policy and regulations, and government agencies to use scenario simulation to determine how to manage land. This is the implications and contributions to knowledge, and it is presented based on the theoretical contribution, empirical contribution, methodological contribution, and practical contribution. The theoretical contribution is this study extended the applicability and predictive power of socio-ecological system theory and complex adaptive system theory to estimate or to measure ecosystem service valuation. Theoretically, understanding environmental degradation using multi-lens approach can improve the environmental sustainability. Empirically, this study contributes to answering the call for modeling and valuation of ecosystem services using the 6 distinct and interrelated concepts of land cover change, driving forces, valuation, ecosystem service scenario, urban and hinterland. Methodologically, it contributes to methodological advancement through utilizing diverse sources of data and improve research tool by adopting interdisciplinary approach of the combination of economics, urban planning, and ecology. And this study has real-world implications to design strategic planning, to design operable land use planning, for payment for ecosystem service, and this study contribute to improve city-region concept from ecological perspective in Ethiopian urban system. Finally, this study had a positive social change to improve the well-being of the urban center population. From the contribution and implication to knowledge, it is suggested this proposal had an environmental degradation model to ensure environmental sustainability and resilience, understanding of land use climate change and its driving forces by applying the simulation and valuation can have the environmental degradation in city region. So this sustainable development model is suggested to have the environmental degradation model in Magala city and in Ethiopian urban system, and to ensure the pillar of sustainability, environment and the economy. This is the suggested features. It is suggested that comparative study and urban center about the nature of the problem to be studied, and future researchers investigate land cover change from ecological system theory. The PACE scheme or payment for ecosystem service is globally and locally at an infant stage. So future researchers should investigate the feasibility. This study is also applicable to rapidly urbanizing cities. It can be also applicable at large scale in urban regions. And the different literature shows that in Ethiopia, there is absence of national assessment on ecosystem service valuation. So future researchers consider the national assessment of ecosystem value in Ethiopia. This is already presented by my advisor. From this dissertation, 3 articles are published. One is about the willingness to pay. It's published in Journal of Economics and Sustainable Development, the New York-based publisher. The second article is about the future land cover chain and its impact on ecosystem services, also published in their online. And the third article is, it has passed through rigorous peer review, and we have both the certificate of acceptance about the historical land cover change and their effect on ecosystem service value. And they are indexed globally in different workbooks, in Google Scholar, in Field University, and other 14 type of index. Thank you very much.
Okay, thank you, Shishay. Very nice presentation with your long time consumed. Now, I want to invite the external invigilator, Professor Haidu Turku. Okay, so I want to comment. I invite you to comment and ask some questions that you have. Professor Haidu.
Okay, thank you very much, Mr. Chairman. I'd like to congratulate Shishay for this nice presentation and also for a very nice dissertation on the dynamics of land use and ecosystem values in locally urban center and its hinterland. This is the first in its kind that I've seen. It is a very good thesis. And also the presentation is very good. I would like to congratulate you for that. I would like also to thank the University for inviting me to this important thesis evaluation. Having said that, I would like to give my comments as usual. Even if it is good, comments has to be given for small improvement, even if it is small improvement. I categorized my comments into 2 general aspects. This one is a general assessment and the other one is specific ones. As a general, I've seen that the thesis is very well written, addressed very important issues, follow general regulation of civil service university thesis writing, and also many editorial errors and writing shortcomings which need improvement. I found it is very good work which will be considered as a basis for future research. I have checked the level of plagiarism in this document and it is only 4%. I was surprised because it is a very low plagiarism results that I have ever seen in PhD dissertation. It is only 4%, which is very low as compared to many of PhD dissertations. I understand from the thesis that you have got 4 publications, but now I've only seen 3. Maybe the 4th one is coming soon. These 4 publications are reviewed in international journals and come out of this dissertation, and these publications assures that the quality of this work meets national and international standards. This is my general comment. The comment is only positive. There is specific, when I come to comments, give some specific issues to be addressed. If you go to the page, starting from the title page, you said land use and ecosystem values. Land use. Sometimes you say land use, sometimes land use, land cover. Land use is a very difficult issue on this big area because land use needs to know of each land. Instead of land use, I recommend that you say you change the title to land use, land cover. Because if you change it to land use, land cover, then whether it is land use or land cover, it will be appropriate for your discussion. But if you say land use, you have to exactly know the use of land. With whether not only built-up area, for example, is land cover, but that built-up area is about what is the function of that built-up area is a land use. For example, it could be residential, it could be commercial, it could be something like that. So instead of saying land use, I recommend that you change it to land cover. Another comment that I would like to make in this title is that why you say Mekelle urban center instead of just simply saying Mekelle city. Is there any reason for that? Because Mekelle urban center, Mekelle city could mean the same, but normally Mekelle is a city. If you say Mekelle city, I think it would be appropriate. Also in the title you say dynamics of land use. You analyze the dynamics of land use, one, but you didn't analyze the dynamics of ecosystem services. But the title says the dynamics of land use and ecosystem service values. Have you analyzed or have you found out the dynamics of land use services? Because I didn't see any values that over time of different land uses or land covered. So this is in title page. In abstract page, you started from the objective, not from the problem. Maybe it's important to first verify why you started this work. What is the problem? What is the issue that you are trying to solve? That should, I think, that should come first. Then, if you know why this study is initiated, then the other issues comes later. But in your abstract, the sequence is you start with objective, then knowledge gaps without knowing the problem. Research problem comes after knowing the knowledge gap. Objective again, research question followed by selection of study area, partial reconnaissance visits again, and then objective. Have you ever noticed that it is a mixed up abstract? Maybe you have to, it is very minor corrections, but you have to really rearrange it in an order where how abstract should be written. So I recommend that you write your abstracts in an acceptable manner. In the introduction part, I see that it has clearly introduced the purpose of the research. And this study combines, as you said, ecology, economics, and urban and regional planning issues. So the objective, the purpose is very clear, and I don't have any comment to give in this section. But when in your description of the study area, I think in this description of the study area in the last chapter of your introduction, the last section of your introduction, if you see figure 1.6 on page 16, is a climate diagram. This climate diagram, I see from the presentation that it has improved a little bit, but in your thesis it doesn't have y-axis. It doesn't have variables on y-axis, and the temperature and the rainfall plot similar. This is not an appropriate way of doing things. You have to, I think you have to correct that. Maybe you have to plot them separately. I think now in your presentation I have seen them separately, but Still, there are some mistakes on this diagram. The literature review, I found it very interesting, the literature review, starting from the introduction, basic concepts and definition, integrating ecological, economic dimension, ecosystem service valuation, theoretical and practical underpinnings has been done very well. Also, you have reviewed empirical literature. You have, after that, after reviewing the theoretical and empirical literature review, you have developed a conceptual framework for the study, which I see is very, very interesting process. Then you have also identified a literature gap, which I don't see in many of the PhD dissertations that are being done in this country. This, I would say that this is a very good and very appropriate way of literature review. And I don't have, except positive comments, I don't have many things to say on that. The methodology part section is also, I found it very elaborated, but you have to explain how values in US dollar for each ecosystem service are allocated. In your methodology, the methodology is very clear for the other parts of the work, but I only can't, maybe I didn't understand, you can correct me if I get it wrong, but you didn't explain how values in US dollar for each ecosystem service is allocated, how it is calculated. I know you have taken some coefficients, you have relied on focus group discussion and so on and so forth, but that is really not very clear. I couldn't understand how that can be changed into practical thing. The chapters, for example, analysis of land use dynamics, as I said, you have to say analysis of land use, land cover dynamics, not land use only, because the use of land, I'm sure you don't know the use of most of the lands, the plots, you don't know. You only know the cover from aerial photographs. So you have to change the topic also to analysis of land use, land cover dynamics. Land use dynamics need very detailed study because you have to know the function of each plot of land. So I suggest that you better analyze land use, land cover as it is more general. One question is why you used the land settlement of 1972, 1984, 92, 2001, 2012, and 2019. What is the specific reason for choosing these dates? Because you didn't mention anything about that, why you selected these dates. You have also used the same methodology, maybe in methodology in land cover analysis in urban and rural areas, which may sometimes give wrong results unless you check in the field, which may give wrong results, and built up area may be similar to unvegetated bare land sometimes. So I don't know how much you have checked in the field, but usually using the same methodology for land use, land cover in urban and rural areas can lead to wrong results. I don't know how you have checked. I've seen that you have checkpoints in the field, but how that is dense enough to really show you the land cover issues. Yeah, the other question is what are unsustainable lands? You say sometimes you have unsustainable land cover changes that have negative consequences on ecosystem service and sustainable urbanization. What is unsustainable land cover changes? Which one is unsustainable land cover changes? Is that the change from cultivated land to urban area, or is it from cultivated land to forest, or why some land cover changes are considered as unsustainable land conversion? while others are considered as sustainable land cover conversions. Concerning Chapter 5 about driving forces of land cover changes, you have suggested population growth is a major driving factor. Climate variability and policy are mentioned as a driver of land cover change. But I didn't see how the policy as a driver have affected land cover change. Population growth is very clear, and climate change is also very clear because it can convert some areas to drying up of vegetation. But how is the policy in Mekelle city and hinterlands have changed negatively the land cover change? I didn't see also no evidence was presented for the decrease in rainfall and increase in temperature. Your data doesn't show that. I mean, in Ethiopian condition, particularly Mekelle is one of the Ethiopian highlands. This area, the general climate model shows that there is no decrease in rainfall amount, but only in rainfall variability. And the temperature, unless it is urban in Thailand, effect, also there is no significant change in temperature. Have you tried to look or investigate into how this change in decrease in rainfall and increase in temperature has changed or affected the land cover change? I personally believe that there is no change, there is no decrease. Generally, there is no decrease or in rainfall, and there is no increase in temperature. Only thing is the variability. You can argue against this, maybe based on your data. In Chapter 6 about quantifying the spatio-temporal variation of ecosystem service values, as I said previously, one of the methodologies for ecosystem service valuation, ecosystem service values quantification, is focus group discussion and adaptive ecosystem service coefficient. Is this, you believe that what you have done is reliable? That is the question. If it is reliable, then you can explain how that is reliable, but if it is not, maybe you can say some words on that. Land cover dynamic affects the ecosystem service values in both negative and positive way. Can you give an example of how land cover dynamics affect the ecosystem service values, both negatively and positively? Because I didn't see any specific land which has affected negatively, specific land cover which has affected negatively, and the other which has been affected positively. I was expecting ecosystem value maps. You have land cover change maps, you have good land cover change maps. I was also expecting ecosystem value map for each of your scenarios of work. Maybe you can, in quantification of spatio-temporal variation of ecosystem service values, maybe you can put these values on the map and produce the kind of map which shows ecosystem value map. Because it is land cover specific, so maybe it is. I know it is a very hard work to do, but is it worth trying that? Is on your question concerning willingness to pay of Mekelle city residents for watershed ecosystem service improvement. I see in your discussion willingness to pay is only for water for Mekelle city. In the notes for other ecosystem services. Also, I see that willingness to pay may benefit only Mekelle residents and not the people living in the hinterlands. How do you think that the willingness to pay, that the Mekelle residents pay for the water, will benefit the people in the hinterlands? Because you don't have an institutional setup which can do that. and the people that are living in the hinterlands will not benefit from these ecosystem services. Only Mekelle residents will benefit. How do you reconcile the benefits of the hinterland people with Mekelle city? Definitely, Mekelle residents will benefit, but as the interests of the people, Mekelle residents and the hinterland people are different, maybe you have to find some sort of compromise. You have envisaged again that Mekelle residents would pay about 8.5 million per month for ecosystem services. Maybe if I'm not wrong, I've got it from the dissertation. This will per month for improved watershed management, which will be over 100 million per year. How could this fund be managed? You didn't say anything about that, because if this fund is not properly managed, then willingness to pay alone doesn't guarantee that the hinterland benefit from that, or the Mekelle residents benefit from that. I think Mekelle city administration residents has to do this form of type of administration. Maybe you have to include this in your paragraph in your thesis. Concerning modeling potential future land cover change scenarios and other effects on ecosystem service values, business as usual is accompanied by spatial planning, even today. Business as usual is accompanied by spatial planning. You don't convert land unless it is informal settlement. You don't convert land, or you don't change land without making spatial planning. Spatial planning could be done at the city level, or you can do spatial planning at the regional, at the hinterland level. Business as usual is also accompanied by spatial planning. Why you put spatial scenario for spatial planning as very important and very special type of scenario, because business as usual is also